Hello and welcome to today's class on epidemiologic study designs. My name is Dr. Ishan Mukherjee and I will be your guide for today's session. So let's look at the contents for today's class. So a brief introduction, the aims of epidemiology, then the tools of measurement, a little bit about incidence and prevalence. Then we'll go into the study designs, which include the observational, analytical, and experimental designs. And finally, we'll be looking at some MCQs that. Let us start with what is epidemiology. Now, John M. Last in the year 1988 stated that it is the study of the distribution and determinants of health-related states or events in specified populations and the application of this study to the control of health problems. Now, the three main components coming to the aims of epidemiology. The International Epidemiological Association states three main aims. One is to describe the distribution and magnitude of the health and disease problems. So who is affected by it and where are they located? To identify the etiologic factors. So to find the probable agents which cause the. This brings us to the basic tools of measurement so that the previously mentioned aims can be quantified. The main ones are your rates, ratios, and proportions. A rate measures the occurrence of a particular event in a population during a given time period. Therefore, the parts of a rate include the numerator, the denominator, a time specification, and a multiplier. Now, if we take the rates can be either crude rates or specific rates. Now, crude rates are actual observed rates. It could be births, deaths, etc. The previous example was that of a crude rate. Now, specific rates, if we take death rates as an example, now deaths due to, say, a specific cause, such as tuberculosis. Our next tool of measurement is a ratio. So it expresses the relation in size between two random quantities. Now, a feature of a ratio is that the numerator and the denominator are exclusive of each other. So an example is the sex ratio, that is the male to female ratio. Now, a proportion is also a type of a ratio, but the main difference is that the numerator is always a part of the denominator. Always is very important here. And generally, proportions are expressed as percentages. An example of a proportion can be the number of children with caries. Let's take a look at incidence. It is a rate that is defined as the number of new cases occurring in a defined population during a specified period of time. Now, important words to remember here are defined population and specified period of time, the new cases. So the formula is the new cases. Next comes prevalence. So a disease prevalence specifically refers to all current cases, that is all the prevailing cases, both old and new, existing at a given point in time or over a period of time in a given population. So based on this, there are two types, which is your point prevalence, that's in a given point in time. Now let's link incidence and prevalence. So a simple formula is prevalence is equal to incidence into the mean duration. So here's an example. So suppose the incidence is 10 cases of a particular disease per 1,000 per year. And let's say that for this disease, the mean duration. Armed with the knowledge of rates, ratios, and proportions, which are our basic tools of measurement in epidemiology, and also with the knowledge of incidence and prevalence, let's see how all this can be applied in epidemiology, which is nothing but the study of disease occurrence in people, that what is the incidence and prevalence. This brings us to the classification of epidemiological studies. Now, broadly, it's classified as non-experimental or observational studies and experimental or interventional studies. As the name suggests, in observational studies, we ask questions. That is dental caries higher in people who eat? Descriptive epidemiology is all about finding out the prevailing conditions. Now, such studies ask three questions in relation to time, place, and person. Time, when is the disease occurring? Place, where is the disease occurring? And person, who are the people who are affected? Steps involved in descriptive studies are: one, defining the population to be studied, that who are the people, whether it's by age, by sex, by occupation, etc. Next is defining the disease to be studied, for example, dental caries, diabetes, hypertension, etc. Next is describing the disease by time, when. So the uses of descriptive epidemiology include that identifying the magnitude and type of diseases present in a community, provide a clue as to the disease etiology, and also provide background data for planning and evaluation of health services to tackle the problem. Next, moving on to analytical epidemiology. So it is the second major type of epidemiological study. Over here, the subject of interest is the individual within the population. And the objective is to test a previously generated hypothesis, a hypothesis which we will come to from our descriptive study. So the major types of analytical studies are the cross-sectional studies, case control studies, and cohort studies. Now, as the name suggests, cross-sectional studies mainly deals with disease prevalence at a particular point of time. We will be covering case control and cohort studies in detail. So starting with case control studies. So they are also known as retrospective studies, TROHOC studies, or case referent studies. So features of the case control study is that both the exposure and the outcome have already occurred before the onset of the diseases. Now, an easy way to remember case control studies is that the study goes from effect to cause. So the effect is already the outcome. For example, say lung cancer. This is the basic layout of a case control study. Now, the direction of the studies is backwards, hence the name retrospective. So at the beginning of the study, the outcome has already occurred. So we have our cases who have the disease, and we select our controls who do not have the disease. Then we retrospect, we go back, look at. So this is how a case control study can be put into a table. So it's a 2x2. This is what is known as a 2x2 contingency table. So first we have our cases. So we have our exposed cases and our unexposed cases. And secondly, for the controls, we have our exposed controls and our unexposed controls. Put this into an example. So smoking and lung cancer. Say we have 33 cases of lung cancer who were smokers and 2 cases of lung cancer who were non-smokers. So that gives us a total of 35 lung cancer patients. Conversely, we have selected 82 controls who do. So how do we interpret these numbers? First is we'll calculate our exposure rates. So we'll find out what is the exposure rate of the cases. Now A over here are our smokers with lung cancer and C are the non-smokers with lung cancer. So we can see a total of among the lung cancer patients, 94 of. Next, coming to comparison of our previous two numbers. So we come to what is known as the odds ratio or the cross product ratio. So over here we have A by B whole over C by D. So that gives us A into D divided by B into C. Now just a recap of what these are. A is our, now Some studies which you should remember the names of, again from the point of view of the examinations. So one is the oral contraceptives and thromboembolic diseases. It's a milestone case control study. And the second one is the thalidomide tragedy. So if you do happen to come across these names, it should strike you as a case control study. Now moving on to the next type, which are our cohort studies. Now, opposite to case control studies, our cohort studies is one that goes into the future. So synonyms include incidence study, forward-looking study, longitudinal study, or prospective study. A major difference between cohort studies and case control studies is that in case control studies, we go from effect to cause, whereas in cohort studies, we go from cause to effect. So we select a population, all of them are without our effect, which is the disease. Cohort studies can be of three types, that is our prospective, retrospective, and amphispective. So mostly cohort studies are the conventional ones, prospective, where at the present we start and we go into the future and observe. Next, in retrospective, what happens is that now coming to the same example of smoking and lung cancer, let's say we've got a total population of 10,000 over here. Now say out of that we've got 7,000 smokers. Now out of the 7,000 smokers, we follow them up and see that 70 of them have developed lung cancer. Whereas among the 3,000 non-smokers, we will get our incidence rates first. So among the smokers, there were total 7,000 smokers, 70 of them got lung cancer. So the incidence is 10 per 1,000. Now among the non-smokers, 3,000 of them, 3 developed lung cancer. So the incidence is 1 per 1,000. This brings us to the relative risk, which is the ratio of the incidence among exposed over the incidence among the non-exposed. Now using the previous numbers, we see that the incidence among the exposed, which is the smokers, was 10, and the incidence among the non-exposed is 1. So we get a relative risk of 10. What this means is that people who smoke have a 10 times greater risk of developing lung cancer over people who do not smoke. Another risk that we are able to calculate from these numbers is what is known as the attributable risk. So that tells us the incidence among the exposed minus incidence among unexposed divided by, again, the incidence among the exposed. What we get from the previous one is the 10 minus 1 divided by 10. We come to an attributable risk of 90%. So how do you interpret this? We can say that 90% of lung cancer cases are due to smoking. Now, looking at some milestone studies again, it's important to remember the names. The first one is the Doll and Hill study, which linked smoking and lung cancer. And the second one is the Framingham heart study. Now again, if you see any of these names, Doll or Hill or Framingham heart study in any MCQs, you should instantly link them to cohort studies. Finally, moving on to experimental epidemiology. So the main aim is effectiveness and efficiency. So to test these two, experimental epidemiology, which is our randomized and non-randomized trials, are conducted. So how did we come about this? Now again, this is something important to remember from the point of view of examinations. The first ever randomized controlled trial was performed by James Lind in 1747 using 12 Navy sailors who were suffering from scurvy. In James Lind's scurvy experiment, the 12 sailors were split into 6 groups of 2, and the following interventions were given to them. And he found out that group 5, which received the orange or the lemon, were cured of scurvy. Hence, he was able to conclude that citrus fruits are a definitive cure for scurvy. Now, this is the basic framework of a randomized control trial. So we've got our population, we select our sample from within the population, and we then randomize them. Now, this process of randomization is what is known as the heart of any randomized trial. So from randomization, we get our intervention and non-intervention groups. Now, why is randomization done? It's done so that every sample has an equal opportunity to be in the intervention group. From there, we follow up to see whether the intervention leads to our desired outcome or not. Now, the different types of study designs include what is our parallel study design. So over there, we've got our samples who are split into two groups, and then the outcome is compared. What happens in a crossover type of study is, say we have our treatment group and our control group. Now they are after giving the intervention, they are observed for some time and then they are switched. So the previous treatment group is now the control group, and the previous control group now receives the treatment, and then again it's compared that whether the outcome is seen or not. Now, some other randomized designs, it's enough just to know these names, are preventive trials, risk factor trials, cessation experiments, trial of etiological agents, and evaluation of health services. Coming to the non-randomized designs, again, it's enough to just know the names. So we have our uncontrolled trials, natural experiments, and before and after comparison studies, one with controls and one without controls. So to summarize again the flow of epidemiological studies, broadly we have our observational and experimental studies. Under observational, we've got population and individual based, which both are again further subdivided as descriptive and analytical. Now in the individual based, we've got our descriptive studies and our analytical studies, which include our cross-sectional studies, case control studies, and cohort studies. And under our experimental studies, we've got randomized and non-randomized studies. Now let's discuss some of the MCQs which might be asked in the competitive exams. Take a look at this question. So what's the data that we can gather from it? They want to identify the cholera carriers and they want to check the proportion. The most important, what you have to see is present at the time submitted to examination. So the examination was done at one particular point in time. Therefore, your answer is a cross-sectional study. There is no retrospection or there isn't any looking into the future as well. It's just at one point in time. Moving on to the next one. Repetition of a study in a given group is panel study, cohort study, group study, and high risk. Now, on the face of it, it seems like the answer will be cohort study, but actually the answer is panel study. This is a bit of an out of syllabus one. Let me explain why. Over here, the question hasn't really stated much. It's just said in a given group. Now, a repetition of a study in a given group is a panel study. We cannot call this a cohort study because in a cohort study, we have to select a cohort, like a group which has similar characteristics, but that has not been mentioned over here. So if you do see this question, just remember that the answer will be panel study. All right, the next one, the term prevalence refers to, the answer over here will be C. Because as we discussed earlier, prevalence is a proportion. So therefore, the proportion of the population affected by the disease is the prevalence. Now, the next one, true about both incidence and prevalence is both are rates, not rates, incidence is a rate, or prevalence is a rate. Now, the correct answer to this is again C, because incidence is a rate, whereas prevalence is a proportion, just as we saw in the previous question. Next, another name for case control studies is retrospective studies. Our prospective studies is the cohort studies, and the cross-sectional studies are known as the prevalence studies. Look at this one. It's suspected that a local restaurant was the cause of a botulism outbreak. Which study design shall we go for? The answer over here is again C, cross-sectional study. Now, similar to the first one, here we'll use a cross-sectional design because at one particular point in time we suspect this restaurant to be the cause of the botulism. There is again no retrospection or prospection, and hence it's not going to be either a case control or a cohort study. Next, what is at the heart of an RCT? It is randomization. It's in the name. A randomized controlled trial is nothing without proper randomization. Next, what if the odds ratio is equal to 1? What does it indicate? High association, low association, false statement, or neither? The answer is neither. We cannot say it is a false statement because the odds ratio means there is no association. So we cannot necessarily claim it as false. We should just say no association. Next, so 20 pregnant women were asked about the history of smoking when they came for their antenatal visit and then were followed up. So what type of a study is this? It's a prospective cohort, because at the beginning the outcome over here is the low birth weight babies. So they came for their antenatal visit. So none of them had delivered. Our groups are the smokers who were the exposure group is the smokers, non-exposure group is the non-smokers, and then we see how many of them had low birth weight babies among the smokers and the non-smokers. Finally, take a look at this one. It's a match the following type. Now, the key to this is pick one and look at the options. Let's take A, for example, a cohort study. It'll either be 1 or 3. So let's see, healthy volunteers or individual. It's healthy volunteers. Again, if you just refer to the previous question, you'll know why. So the answers will either be A or B. Now, how do we determine which is which? Let's look at, see, B again. B is 3, so we know that for sure. Let's take a look at C. So C is either 4 or it is 2. So let's see, what is C? It's an RCT. So it'll either be population or patient. Now again, as we discussed, that an RCT is conducted on individuals. So again, it will be patient. So now you know that, okay, A is matched, C is matched. There are no other options which stayed the same. So you can say that the answer for this is A. That's the best way to tackle these sort of questions. Now, if you want to read up a little more on the subject of dental public health, there are 2 very good textbooks, one by C.M. Maria and the other one by S.S. Hiramat. So do give these a look. And if you want to further delve into the subject, there is another textbook by Park, so you can check that out as well. So this brings us to an end for today's class. Thank you for sticking around till the end. Now, if you have any doubts, do reach out to our team for further assistance, and all the best.